Good morning, everybody. I'm going to give a brief talk on what I'm intending to do for my master's thesis project, which primarily focuses on the question of how important it is to be able to hear with both of our ears. So for most of you in the room who have normal hearing, you've probably never really thought about why it's important or why it's beneficial, because hearing for you is something that's completely and totally natural, and you just do it without really thinking about it. So the question is, why is binaural hearing important? The first thing that I want to talk about is music perception. Binaural hearing is really important to try to help parse out melodies in music. And a lot of people with hearing impairment cannot necessarily appreciate music in the same way that they once did, because they cannot pick out melodies, or they have problems understanding the rhythm or differentiating individual instruments. For, say, if you preferred the strings, for example, you can't necessarily pick out the violins that are playing in an orchestra. Another reason why binaural hearing is important is because it helps us to perceive speech in noisy environments. The idea here is that there are signals that arrive, or an acoustic signal that arrives at both ears, and there are small differences that the auditory system can take advantage of to try to direct attention towards the speaker and drown out all the background noise. And the last reason that I'm going to address, because that's what my research project is heading towards, is the importance of binaural hearing for sound localization. And again, it's the same idea as the benefits provided in speech perception, where you have small differences in the acoustic signal arriving at both ears, and that these differences can help you to pinpoint where a sound is coming from in space. So we are going to be looking at sound localization abilities in hearing impaired individuals, and I'm just going to give a brief highlight of how hearing impairment works. So if you look at the normal hearing individual, which is on your left, the purple snail-shaped organ is the cochlea, and this is responsible for converting the acoustic signal into a neural impulse. And it's those little pink hair cells that specifically perform this task. So what happens is they convert the mechanical fluctuations in the fluid that's moving through the cochlea into a neural impulse. But what happens in a completely deafened cochlea is these hair cells eventually start to die, so you cannot get these neural impulses ongoing. So essentially, the hair cells themselves are the link between two separate chains, one which represents the peripheral part of the auditory system, which would be your ears, eardrum, the little bones just before the cochlea, and then the central part of the auditory system, which is all of the nervous system components heading up to the brain. Okay, so a pretty big question right now with respect to restoring binaural hearing is what the best and most effective method is. And this is because of progressive developments with cochlear implants. This is an alternative to hearing aids, which can be used to directly stimulate the auditory neurons, and it bypasses those little hair cells. So essentially what happens is you get electrical stimulation of the neurons heading up towards the brain, and you don't have to worry about all the stuff that's going on in the peripheral nervous system. So this is what I would like to call the bionic ear. It's not, you're not using your normal processes necessarily. We're kind of jump starting it with this mechanism or tool. Now, a different method of treatment is the hearing aid. And all the hearing aid does is it takes in acoustic information, boosts up the level of that sound, so it would be kind of like a volume control on your remote. And then what happens is that information goes through the normal passages, and it's a form of acoustic stimulation for the auditory system. Now, the big question is there are individuals that can still have some residual hearing and can take advantage of their hearing aid, but they may not necessarily get all the benefits, and they might qualify for a cochlear implant. The problem is that when you try to restore hearing binaurally, we don't know whether it's more effective to give an individual 2 cochlear implants, or to give them 2 hearing aids, or to give them a cochlear implant and a hearing aid. And the big issue is that each of these devices provides certain benefits and gives you access to certain cues, but they're kind of different and in opposition to one another. So a cochlear implant can restore hearing for high frequency sounds, but the hearing aid can restore the acoustic information for lower frequency sounds. So the idea is, do we give individuals 2 of the same with particular parts of the acoustic signal missing, or do we give them 2 different devices and hope that the brain and auditory system can deal with this to get all of the information that we need? So my master's thesis project is going to be looking at some preliminary stuff that's going to go towards a larger collaborative study that's ongoing at the National Center for Audiology. There are several labs that are involved, and we're also we're getting some input and help from members of the cochlear implant program over at the University Hospital. And the idea is that we're going to look at individuals in this study, is that we're going to look at individuals who are using hearing aids in both ears, get some measures, then they're going to undergo 1 implant surgery. We're going to test them at several points over the course of a year and on the same outcome measures, and then they're going to undergo a 2nd implant surgery and again test them under these same outcome measures. So the outcome measures of interest are whether people are able to perceive speech and noise, what their perception is of sound quality. We're going to look at some different psychoacoustic measures and their ability to localize sound, which is where my stuff comes into play. So this is a picture of my supervisor, Dr. McPherson, in the bell-tone anechoic chamber, which is where we're going to be testing participants. The funny walls basically absorb all of the sound in the room, or try to absorb all of the sound in the room. And Dr. McPherson's standing in the middle of a 360-degree speaker array. So there will be sound bursts coming from all different directions, and a head tracker will be worn by these individuals, and they have to orient to the direction from which they think the sound has come. What I'm going to be looking at specifically is has 3 components: characterization, correlation, and trying to determine whether the assistive devices are beneficial or not. And so what we're trying to do is get an idea of whether the measures that we're performing to try to assess these individuals' relative benefits are effective in a stable population. So we're going to be recruiting individuals that have hearing aids bilaterally, cochlear implants bilaterally, and bimodal users, so they have a hearing aid and an implant. And these people will have been using these devices for a relatively long amount of time, so they're acclimatized to what they're listening to. And so what we're going to do is we're going to put them in this environment and try to characterize their abilities. So there's going to be a couple of different methods to try to look at whether they can localize sound effectively or not. And then we're going to try to correlate their abilities in sound localization with their natural sensitivities. So we're primarily looking at interoral time differences. So they're going to be getting information at marginally different and small time differences from each of the ears, see if they can localize well based on that. And we're also going to be looking at interoral level differences. So again, very, very small differences in the level or volume of sound coming to each of the ears, and see if they can effectively localize with that. And then lastly, we're going to try to recruit some normal hearing listeners to see if we can do simulation experiments where these individuals will be listening over headphones to something that sounds like what we believe an implant and hearing aid might sound like based on the processing that these 2 devices do. So we're going to try to see if these individuals can accurately localize sound with what they would hear if they had hearing impairment and were using these restorative devices. So hopefully the results from my study will help to contribute to this greater collaborative study, and we'll get a bigger idea or a better idea of how to restore hearing for individuals who have bilateral hearing impairment. And that's all I have to say. So thank you very much.